Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq. Today I'm going to present about case Highland Tower. The location is Highland Tower, is Selangor, Malaysia. The date of the collapse 11 December 1993. The time is 1:30 p.m. Saturday afternoon. Okay, for the historical of the Highland Tower, the Highland Tower tragedy was one of the most tragic tragedy in Malaysia. It is the first case of the involved high-story apartment collapse. Highland Tower consisted of the three 12-story block of the apartment known as blocks 1, 2 and 3. It was constructed between 1975 and 1978. Directly behind the 3 block was a step slope A, stream originating up slope from the meteorological land flows across part of the slope. The Highland Tower were once notorious in the 1980 and early 1918 for the being a popular spot of the wealthy people. For the cases of the tragedy, in generally they are manufactured. The tragedy from the happen. Okay, for the first construction building on the edge of a hill, even is not suitable, especially in the equatorial and tropical climate with the high rainfall. Second, building apartment on the hillside is also again with the land conservation 1916. The actual property the development carry out the hillside with slope greater than 80 degree for the reason connected for the environment. Inconsistency between a land conversion act with the environment quality 1674.
On December 11, 1993 at 1:35 p.m., the first tower of the Highland Towers apartment complex in Selangor, Malaysia fell, ultimately killing 48 people. The cause of failure was attributed to a landslide that occurred due to pipes that burst, allowing for the barren ground near the site to wash away. The pipe system was originally placed on a hill nearby the towers to divert water from a stream that normally flowed onto the site. Trees had also been previously cleared from that hill for separate housing development project, so the soil had no protections against erosion. During a 10 days monsoon, the pipe burst from the large amount of water flowing to them, letting that volume of water flow down the hill. The combination of monsoon rains and loose soil led to a landslide that brought Block 1 of the Highland Towers with it. A mass of mud equivalent to 200 jumbo jets around 100,000 square meters came sliding down the hill, breaking retaining walls and finally destroying the pier foundation system of the tower. The tower was able to stand for a few days and showed warning signs of failure, such as cracked wall and pavement. However, Tower 1 was destined to fall. Luckily, some residents were able to evacuate the building prior to the collapse because they knew something was wrong. Residents in the neighboring towers 2 and 3 were quickly evacuated and not allowed to return for fear of those towers also collapsing. Tragedy like this can be difficult to prevent. However, certain measures can be taken to protect buildings from landslides. Firstly, the effect of erosion should be taken into account when clearing a plot of land. Secondly, The retaining walls should be designed to be stronger as well as go deeper in the ground for further prevent large masses of land shifting. In Malaysia, there are times of the year with constant downpour. It is difficult to design for such catastrophes. In this case, it seems that all the necessary precautions had been taken to prevent such a tragedy. Since this was such a tragedy, the name of the architect, engineer, and construction were left anonymous during litigation. Okay, so for the implication of the tragedy that happened to Highland Tower is about 48 people lost their life that has been discovered and identified. The victims are mainly Malaysian with 12 foreigners. That is Britain, Japanese, 2 Indian and Korean, and lastly is 3 Filipina and 3 Indonesian. This has caused loss of property worth millions of ringgit. Also review of acts of environment by the authorities. This caused damage to the environment seriously affected area. The possibility of public response on the hillside housing will decrease. Also, this raised concern among developers. Environmental damage of surrounding area and amendment of existing act related to environment. Lastly is possibilities of decreasing demand over resident on hillside. Construction of building on the edge of a hill is not suitable, especially in equatorial and tropical climates with high rainfall. Building apartments on the hillside is also against with the Land Conservation Act 1916. The Act prohibits the development carried out on the hillsides with slopes greater than 18 degrees for reasons connected to the environment. The another outcome we learned is that it was not proper to join an edge pipe of Bukit Antarabangsa project which was under construction, with the pipe of East Creek water stream made to bypass the water from Highland Tower. So for the conclusion is, in spite of years of accumulated experience, the ability of the geotechnical occupations to express reliable calculations for slope failures or stability remains destitute. This is mainly due to the abundant sources of doubt that take over performance crack in geotechnical engineering. Essential natural unpredictability of soil possessions, lack of data, limit of models, and above all human fear are some of the challenges that geotechnical engineers has to bear in routine. In this regard, probabilistic techniques are more suitable option to quantify and incorporate uncertainty into slope analysis and design as compared to the traditional law of safety factor. In actual, this study concedes out that dependability theory can be used as a logical substitute and found it much more reliable.
Hi, my name is Najwa, F2047, and this is for case 2, which is field slope in Putrajaya. On 6th of January 2001, a 25-meter field slope built in 1998 failed, following an overnight period of significant rainfall. The breakdown results in 2 reinforced earth walls failing, the newly finished jetty and boat docking facilities at the bottom of the field slope collapsing, and a portion of the road at the top of the field slope collapsing and cracking. The Public Works Department of Malaysia was then asked to investigate the failure to ascertain its scope and root reasons. This case provides an overview of the work done during the field inquiry as well as the study's conclusions, and then corrective actions were recommended. For the background in this case is situated in Putrajaya. The majority of the government agencies are located in Putrajaya, which Malaysia has designated as a federal territory. It is situated around 35 kilometers south of Malaysia. The 1990s years Malaysia economic boom and subsequent rapid growth led to the development of the Putrajaya region. Even though the majority of the government buildings in Putrajaya have been finished, construction is still ongoing.
We will explaining about cause of the failure. The cause of failure can be attributed to the following reasons: the discovery of a thin layer of pebble clay that was pressed out during the failure. The field slope may have become unstable and settled as a result of this soft layer. Second, the presence of loose material, which suggested good compaction during construction, may have prevented the material's current state, which was caused by water slipping into the slope and loosening it. After the lake was filled with water, the groundwater level in the failing slope increased. When compared to yearly measurement taken before the field slope was moved, the groundwater level rose by around 9 meters due to the factor of safety force being decreased from 1.051 to 0.935 using anticipated soil conditions. This has made the slope unstable. Heavy rains contribute to the groundwater level rising to a dangerous level and making the slope unstable, which set off the failure. As a result, the slope became unstable. Back analysis of the field slope. Back analysis of the field slope was carried out using the slope software, Slope W. The back analysis was carried out for two cases using typical soil parameters used in Malaysia. First, the field slope prior to the construction of the lake. Second, after filling of water in the lake have been carried out.
Okay, this is learning's outcome. Firstly, some of the value investigations findings include the absence of the piling slab at reinforced earth wall that was supposed to be there based on the place, and the fact that the lake was filled after the field slope was built, which raised the groundwater table. And then it was discovered that the groundwater table at value was significantly higher than what had been estimated during the site research process. Water leaks were also seen from the failing area.